All right, lesson 10.2, probability. Here's the deal. This is the beginning of this is it. This is what I like. Are you ready? Here we go. The probability of an event happening is the chance of it happening, right? I mean, what is the chance? I mean, it's something that you don't know. Like when I roll a dice, if I say, what's the probability of me rolling an even number? You don't know whether or not I'm going to roll an even number. Do you agree? When I roll the dice, do we know what's going to happen? No. There's just a chance. We know what the chance is, right? If I had a six-sided dice and I said, okay, what's the probability that I roll a 6? Is that likely to happen? Is it likely that I'm going to roll a 6? No. The chances are I'm not going to roll a 6, right? The chances are I'm not going to roll a 6. It's not so rare that you would fall over dead because you're so shocked that I rolled a 6, but the chances are you're not going to roll a 6, right? So probability is the likelihood of something happening. And you write it like this. If I ever give you like this and I give you a P in parentheses, that means the probability. Okay? P in parentheses means the probability. All right? So here's the deal. Let me explain. Okay, so here's the deal. I'm going to show you the secret formula for probability. Ready? It's yays over ways. That's my secret formula. Yays over ways. Write it down. Write down yays over ways right now. Somewhere. Yays over ways. And I'll explain that in a second. Yays over ways. Okay, here's the deal. Here's how probability is figured out. You take the total, you take the number of favorable outcomes. The number of favorable outcomes. Okay. Over the number of total possible outcomes. The number of possible outcomes. Now, here's what I've done. I've reduced this to be this. What is a favorable outcome? If I said, what is the probability of me rolling an odd number? What would be a favorable outcome? I want to know what they would be. What would be a favorable outcome? I'm about to roll the dice. What would be a favorable outcome? If I'm trying to see what is the probability of me rolling an odd, what is a favorable outcome? Give me one. 3 would be one. What else? 1. What else? A 5. The favorable outcomes are when you go, yay, I got it. Right? Favorable outcomes is when you go, yay, it worked. You see what I'm talking about here? See how I shortened it from number of favorable outcome to yays, right? Yay, I got it. Number of possible outcomes means that, listen, when I roll the dice, what are the possible outcomes? What are the possible things that I could roll, Slayton? 1, 2, 3, 4, 5, or 6, right? Those are the total number of possible. So that's why I put down, instead of putting number of possible outcomes, I put ways. There are 6 ways for me to roll a dice. Does that make sense? There are 6 ways for me to, end up with something. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Does that make sense? Yays over ways. So, and it turns it into a ratio. That's it. Let's look. If I said, what is the probability of rolling a 4, okay? What you always want to start with is, start with the ways. Always start with the denominator. How many ways are there for me to roll a dice? How many total different, there are 6. There's 6 different possible outcomes, right? 6. How many yays are there for me to roll a 4?
1.
There's only one way for me to roll a 4. I can roll a 1, 2, 3, 4, 5, or 6. How many ways do I go, yay, I got it? 1. There's only one way. There's only one side of that dice that has a 4 on it, right? So, the probability then, you would say the probability of rolling a 4 is, you wouldn't say 1/6, you would say 1 out of 6. That's how you would say it. 1 out of 6. In other words, every 6 times I roll a dice, how often should one of the numbers land a 4? 1, right? Does that mean that if I roll the dice 6 times that it will definitely land on 4 once? No. Is it possible that I would roll 6 times and all 6 of them be a 4? Is that possible? Yes. Is that likely? No. Is it possible? Is it possible for me to roll it and have it be a 4 6 times in a row? Yes, it's possible. Is it likely? No. Right? That would be one where you would be like, oh my goodness, you might even fall over on the ground and be like, oh, I'm so shocked. Right? That one would be really crazy. You guys try one. Try one here. What is the probability of rolling a 1 or 2? All right. What do we start with when we decide how to write our fraction? We do the bottom, right? We do the denominator, the ways. How many total ways are there for me to roll a dice?
6.
There's 6, right? There's 6 possible outcomes. There's only 6 things that could possibly happen. 6. How many yays are there? How many things could happen that I would go, yay, I did it? 2. I could roll a 1 or a 2. There are 2. Does that make sense? Does it make sense now? There's 2. I could roll a 1 or a 2. If I roll a 1, yay. If I roll a 2, yay. If I roll a 3, oh. If I roll a 4, oh. 5, oh. 6, oh. There's only 2 yays. Right? Make sense? This can be reduced. You actually do reduce this. You would say the probability is 1 out of 3. I mean, it's not that 2 out of 6 is wrong, but you want to reduce it to something that's even more palatable for people. Okay? Try another one. What is the probability of rolling anything besides a 5? Okay, well, how do we start this? What do? Start with ways. How many total ways are there? 6. How many yays are there? How many ways can I go, yay? There's 5, right? What's the only one that would make me not happy? A 5. Here's the deal. So in this situation, I mean, this is really simple and very straightforward. In this situation, you have the probability of re-rolling what I want, and that is 5 out of 6. Remember the word complement? Do you remember the word complement we used when we were talking about angles and stuff? What do you think the complement of 5 out of 6 is what completes the whole number. So if there is a 5 out of 6 chance that you're going to go yay, what is the probability that you're going to go, oh? 1 out of 6. Does that make sense? 1 out of 6. The complement is the other side, is the opposite of what you're looking for. So the complement of this would be 1 out of 6. Let me show you. Here I'm going to make a little spinner. No, I don't want that one. Okay, and we have a 1, 2, 3, 4, 6, 7, or 8. What is the probability that I roll? That I spin. Probability of spinning something bigger than 5. Do that for me. Try. Does spinning 5 make you go yay? No. Okay. What do I start with? Ways, the bottom, right? How many ways are there for me to spin this thing?
8.
There are 8, right? There's 8 different possibilities. 8. How many ways are there? How many yays are there? How many different things could happen that I would go, yay, I did it? There are 3. Name them for me. What could I spin? 6, 7, or 8. Right? I could spin it 6, 7, or 8. That's it. 6, 7, or 8. 3. Okay. There's a 3 out of 8 chance. Everybody say 3 out of 8. This is 3 out of 8. There's a 3 out of 8 chance that I go yay. That I have a favorable outcome. That I do what I was trying to do. What is the complement for this probability? What is the complement of this event? 4 out of 8? It would be 5 out of 8. If there's 3 ways for me to go yay, then there's exactly how many ways for me to go, I didn't make it? 5. Right? Makes sense? Does that make sense? The complement would be 5. It's what is the probability of the other thing happening? Okay? Okay, I'll give you another kind of question here. It's kind of neat. It's different. Get used to these. This is how I roll. Okay, this is going to be a tricky one. Ready? That's a bag. Oops. Okay. There's 5 objects in the bag. Right? There's 5 objects in the bag. What is the probability of me pulling out? Of course, I'm not looking in the bag. I mean, I'm reaching into the bag, and I'm not looking at what I'm pulling out. Of pulling out a triangle. Try and figure it out. All right? First of all, what is it asking me to do? What's it asking me to do? Sladen? Take out an object, right? I'm taking out an object out of the bag. And I'm asking, what is the probability that what I take out is a triangle, right? First thing I do is I go to ways. How many total things can I pull out of there? There are 5. Did anybody here put 4? That's good. There's 5 objects in that bag, right? 5 objects in the bag. What's the probability that when I pull out, how many yays are there in that bag? 1. The probability is 1 out of 5. What's the complement to this? 4 out of 5, right? 4. Now here's the deal. Which is more likely to happen? That I would go yay or that I would go right? I didn't make it. There's only if I did this 5 times, if I did this practice thing 5 times, where I put the 5 objects in the bag and I pull one out and and I put it back, and how out of say 10 times that I did this, how often would I pull out the triangle? You talk without raising your hand a lot. Jared?
3 out of 2.
3?
3 or less.
How many, Sladen?
2.
2, right? What's the probability again? It's 1 out of 5. Which means that if I did it 5 times, if I did this thing 5 times, how many times should I pull out the triangle? 1. If one time out of 5, then how many times out of 10? 2, right? If I did the experiment 15 times, how many times should I pull out a triangle? 3. Does that mean that I will?
No.
Is it possible that I would pull out a triangle every time? Is that possible? Yes. Is it possible that out of 15 tries, I would never pull out the triangle? Yes. Right? But it doesn't change the probability. The probability says that I would, every 5 times, I'm going to pull it out once. Make sense? Okay, here's the next question. You ready? So I'm going to see if you guys can handle it. I'm not kidding. I will be curious. See if you can do that one. All right. Nothing changes here. Go down the list. What's the rules? What do I do first? Ways. How many ways are there? How many different things are there? 5. Now, how many yays are there in that bag? How many different? Yay! I got it. How many times? What is the probability? How many? There's 2, right? There's 2 stars. 2 in there. How many of you got 2 out of 5? That's what you put down before I said anything. Good for you. That's really good. So then what's the complement of this? 3 out of 5, right? It's not. If you say 3, that is wrong. What's the complement to this? 3 out of 5, right? Even in this situation, is it likely that you're going to pull out a star? Is it likely? Do you guys all know what the word likely means? Yeah. Likely means that it probably is going to happen. It means that there's a bigger than 50-50 chance. Is it likely that I'm going to pull out a star? No. There's only 2. It's 2 out of 5. Is 2 out of 5 more or less than half? Less. So is it likely that I'm going to pull out a star? No. Is it likely that you're going to lose this? If you reach your hand in there and you pull out something and you go, is it likely that you're probably not going to win, that you're going to lose? Yes. Does that make sense? Okay. question.
Isn't it like still when the stars would be considered likely to be more stars than any other shape?
No, I mean, if now here's the deal. If I was to ask you, is it likely, even then, is it likely for you to pull out a star? The answer is no, because you're likely not going to pull out a star, right? There's only 5 objects and there's only 2 stars. You're likely going to pull out one of the other 3 objects. Does that make sense? I don't know. You're more likely to get a star than a triangle, or you're more likely to get a star than a square. But when you just reach your hand on the object, are you more likely to pull out a star or something else? Something else includes everything, right? That means that you're not likely to pull out a star. Makes sense? Now, would it shock you if you pull out a star? No, because it's almost half, right? It's almost half. Of the 10 of you in the room, how many of you will probably pull out a star? 4 of you, right? Does that make sense? So it's not like you wouldn't be shocked. Okay. Let's see if there's anything else here. Yeah. Let's talk about this too. You ready for this? The probability, there's a range. Did you know that probability, all probability, I don't care how big it is, we're talking about the odds of winning the California State Lottery or the Powerball or the Mega Ball or whatever it is. I mean, the hugest, where people are winning like hundreds of millions of dollars. Did you know that probability always lands somewhere between what 2 numbers? 0 and 1. Probability always lands somewhere between 0 and 1. Always. In fact, here's the deal. Here's 0 and here's 1. If I was to do this, here, let's do this right here. I'll do the bag thing again. Here's a star, circle, triangle. And I said, okay, what is the probability, people? Are you ready? Are you paying attention? What's the probability of me pulling a square? What's the probability of me pulling a square? I won't warn you again. What's the probability of pulling a square? 0. I can't pull a square, right? So you would say that is impossible. You can't pull a square. It's impossible. 0 is no chance. No chance. Or impossible. Does that make sense? 0 means that there's no chance. You cannot do it. Right? It would be like me taking a dice and rolling and saying, what's the probability that I roll a 7 here? No chance. None. I can't roll a 7. Agreed? What if I said this? Here we go. Here's the next question. Same thing. There's a bag. Here we go. What is the probability? What do you think I'm going to ask? What's the probability that I pull a star here, people? It's 4 out of 4 is a good answer. Certain. What else? What's another word you could use? 100%. What else? Guaranteed. Always, right? I mean, these are all. So, and it starts with, it's 4 out of 4. If we actually do the probability, isn't there 4 ways and 4 yays, right? So it's 4 out of 4, which is just the number 1. It's guaranteed or certain. Lots of words for it, right? Impossible to not make it. Whatever. As long as you get that it always lands, probability always is a fraction between 0 and 1. 0 being impossible, and 1 being certain or guaranteed. Does that make sense? Does that make sense? And that's why probability is cool. It's because you're dealing with, now listen, the closer you get to here, the closer you get to there, the more likely, the better chance, the more likely you are that your event's going to happen. The closer you get to here, the less likely or the less guaranteed things are going to be. Does that make sense? Where do you think the probability of you winning the California State Lottery, the 10, 20, $30 million lottery, where do you think that lands on the number line here, on the impossible to guaranteed deal?
Practically impossible.
You think it'd be near 1? Like it's almost guaranteed that you're going to win the California? Oh, yeah. Where do you think?
A little bit behind the middle.
Oh, really? No. Winning the lottery, where do you think?
Literally right
I mean, like you couldn't, it is so close to, it would be so close to the zero that you couldn't even tell. You know what I mean? Like it is so impossible. So, well, in the SOAR class, I actually show them how to figure out the odds of winning the California State Lottery. There's actually a mathematical way of doing it. And I don't show them what the odds are until afterwards. And we actually figure out the ping pong balls. You know, you've seen the lottery, right? The ping pong balls, and there's all kinds. And we show them how, boom, and it's in the tens of millions. And it's 1 out of 60-something million. Yeah, so that would be 1 over 67 million or whatever. Is that likely to happen? That means that there's 67 million balls in there and you have to pull out the one that you need.
So
Likely? No, not at all. You're more likely to get struck by lightning than you are to win the lottery. And that is true. That's true. You're more likely to get struck by lightning. There have been more people that get struck by lightning than to win the lottery. Yes?
I think it's also something about almost the same amount of likeliness as getting hit on a piece of a comet.
Right, exactly. That's exactly right. It's that much. So here's the deal. It's such small odds that it's practically impossible. Right? Does that make sense? Practically zero. In fact, my saying has always been, the odds of you winning the lottery are pretty much the same as if you didn't play. Oh. You know what I mean? So really, when you take that $5 and you go buy some lottery tickets, you're pretty much just giving them $5. You know? Question?
did you see how David Blaine did?
Oh, yeah, the magician. Yeah, he's fun. David Blaine is definitely funky. He's done some things and
Did you see what you had the lottery ticket though?
no.
He gave the guy the win, basically. He thought told the guy to give him money to get in the lottery. Like his whole guy told him to give him money to get him a lottery card.
Yeah, no, I didn't see that, but I believe it. That guy does some stuff that is insane. Like, I don't understand it at all. We'll talk about it later. It's crazy. Anyway, I think that is going to be the deal. One thing, I want you, they tell you in this to write down in some of these, they ask you to write your answer as a decimal. I don't care. I don't want you to do that. I want you to leave it as a fraction. It makes things easier. And that really is more likely the way that probability is written. Okay? So that's what I want. You leave it as a fraction. Otherwise, I think you guys have got this. Okay? Your questions for your homework. We don't have homework. We're going to be correcting this on Monday because it's half day tomorrow. Page 486, 4 through 16, even, and 29 to 35. Even.